Hello everyone, today we're going to look at usaco-training ordered fractions. In this number we're given an integer n, which is in between 1 and 160. And we're supposed to print all the reduced fractions between 0 and 1, such that they have the denominators less than or equal to n. So for example, for n equals 5, 4 over 5 would work because 4 divided by 5 is 0.8, which is in between 0 and 1. And 5, which is the denominator, is less than or equal to n. Okay, so we're just supposed to print them in the order of magnitude. Okay, so let's actually just put it up. So we have n, we have n equals 5. So you know that the denominator, let's call this denominator, you know that it must be greater or equal to 1, and it must be less than or equal to n. And since, basically, so you have your numerator as well. So since the resulting of this fraction has to be in the range of 0 and 1, then the numerator can't be greater than the denominator. Because if it is greater, then it would exceed 1. So it must be less than or equal to the denominator. And it must be greater or equal to 0. Okay. So, and also, since the maximum of n is 160, we can actually loop through all the possible numerators and denominators, and we can basically count that fraction as well. So now there's this problem that we have. For example, if we have n equals 6, so you know that 1 over 3 is a possible fraction because 3 is less than or equal to 6, and this is the resulting of this is in the range of 0 and 1. But then when you look at 2, 6, you might double count this because you treat this as like different fractions. But actually, since 2 over 6 can be reduced to 1 over 3, these two are actually identical, so you shouldn't count them twice. So what we can do is that, so we can we can define a GCD of A and B. So GCD is basically the greatest common factor between two numbers. So then if you have 2 over 6, you know that the GCD of 2 and 6 is 2. So then you would have 2 over 6. You divide this by 2. You also divide this by 2. This would be resulting as 1 over 3. And since 1 over 3 is the reduced fraction, you can just insert this into a set, then count all the items. Okay, so let's actually start coding. Okay. Okay, so we're given a number n, so you can read n. Oh, whoops. Read n. Okay, so let's use a set of a pair int int. Let's call this our answer, or our fraction, so fracs. Okay. So now you know that your numerator can be less than or equal to your denominator. So let's call this for int numerator has to be equal to 0. Numerator can be less than or equal to, let's just say, n. Numerator. So then, since your denominator needs to be greater or equal to your numerator, then you can int denominator, it would be equal to the numerator. And then denominator has to be less than or equal to n. Just increment that. Okay, so now we need to have our GCD function. Okay. Or like we need to simplify this. So let's call this our GCD. It would be equal to GCD. So we have this built-in function. So GCD of numerator and denominator. Then you would just you just divide by your GCD. And then you can just insert this into your set. It will be numerator, denominator. But then there's actually one more problem that's going to emerge. Since we actually want to sort this, the whole thing, we should actually have we actually want to like compare it correctly. So let's call this our which is our fraction. So it should be, let's call this a double, and a double is basically a floating point integer, so it can be like more precise. Then you can have your parent int. So we know that when our set would first go by our double, which is good since we want to compare it by the order of the magnitude. Okay, so we, instead of doing this, we can also do okay, when you insert it, you would divide it by so the first one would be 1.0 times num divided, or this is our numerator divided by our denominator, and then because the 1.0 just converts it to a floating point integer. Okay, so here we go. So now we just need to print out our items. So basically for frac f in fracs, then you just print f dot second dot first, f dot second dot second. Okay. So now I think there's also one more problem, because for 0, I'm not actually sure what the GCD is, so we can actually calculate that separately. So basically, because it might like count this like several times for like 0/1, 0/2. So let's just do this beforehand. So s dot insert, this would be 0, this would be 0 and 1. Okay, so let's actually run this. And this is ordered fraction. 1 second. Okay. Let's run main. Let me fetch the input. So we have 5, yeah. So it's compiling. Okay, it's still compiling. Let me actually just put my information here. This is frac 1. Wonder why it's compiling so long. That's weird. That's weird. Oh, it's running, so 5. And so we're just reading n, and this should actually print out the f dot first, f dot second. Let's actually just make a note here so we can see how n equals to n. Let's actually run this again. So n equals to 5. That'd be equal to num. I wonder why it's like running so long. That'd be equal to numerator. It has to be less than or equal. So let's actually print this out. So we have numerator divided by denominator. Okay, well, so the numerator is actually not equal to 1. Oh, so actually shouldn't change my numerator here. So actually, let's call this int numerator 2 and int denominator 2. And it would be equal to the numerator divided by, because I'm actually altering the value here, so it might go as an infinite loop. So here, just change it to numerator 2, denominator 2, here, and here. Okay, so I think we can actually remove that, and let's see. Okay, so 5. So 0, 1, 1, 5, 1, 4, 1, 3. And that looks correct, other than we have to put a slash, not a space. So let's just submit it. Free open, this is frac1.in, read and stdin, and free open frac1.out, right, std out. Okay, let's submit it. Okay, so let me select the file. Okay, this is ordered fractions. And here we go. Okay, so it looks like that is right. So if you have any questions, feel free to leave them in the comment section below. Bye.